Okay, today we're going to talk about the viability of a solution method. What this is asking you for is the method you're using to solve a good method or not? So, for example, if you have a two-step equation, something like 2x plus 5 is equal to 7, your solution method is to subtract 5 from both sides, and then once you do that, you would divide both sides by 2. Now we know this works, but the question is why? That's what this is asking you. So to answer this, the reason you can subtract -5 from both sides, or add -5 to both sides and divide both sides by 2 is because of balance. We are trying to keep this equation balanced. That's why you must do the same thing to both sides, is to keep the balance of the equation or to keep its equality. So if you can answer this question, then you've demonstrated that you can understand the viability of a solution method. This method is viable because we're keeping the equation balanced at all times. A similar thing could happen with a series of equations, or a system of linear equations. So let's say I have another equation here, 3x plus y equals 10, and we'll add a y up here. And one method that you know how to solve is that you're going to subtract 3x from both sides. So you get y is equal to 10 minus 3x, and then we substitute it. And the question was, why are we allowed to do that? And in class, we demonstrated that when you do this, you get a series of graphs that are equivalent. So what happens is, say that here's your grid, and here is your initial graph, and here is your second graph. When you substitute this in and solve for it, you're going to get either this equation that goes right through that origin, or through the intersection point, or you would get the x equals equation, which would be up and down. So what happens is this intersection point between this line and either of these two lines is the same intersection point as the original two lines. So the reason substitution and elimination, for that matter, both work is because the intersection point remains the same. And the intersection point is the solution. So as long as the intersection point remains the same, then this solution is viable. So we're talking about methods for solving. So anytime you have a method for solving, the question is why can I do that? So if you're answering why I'm allowed to do that, then you're answering this question and demonstrating that you understand the viability of solution methods. So a quick recap: it's things solving, like two-step equations, multi-step, variables on both sides. You're trying to keep balance, and as long as you keep balance on your equation by doing the same thing to both sides, the solution is viable. The solution method is viable. For things like systems, what you're looking at is that you are creating an equivalent series or system of linear equations because they share the intersection point. And as long as the intersection point remains the same, then the solution is the same, because as you know from graphing equations, the solution is that intersection point. So you need to make sure the solution has the same answer to your new equations because the intersection point remains the same. If you have questions, make sure you ask.